Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering geometry, lesson 3-1 on the properties of parallel lines. This is a very important lesson, you guys, so make sure you take good notes and pay attention. All right, we have lots of vocabulary to go over today, so we're going to start. It's a little bit out of order from your textbook, but it makes it, I think, easier to understand this way. So a two-column proof you guys have seen in your practice and in your lessons so far, and it literally has two columns. One column has the statement and one column has the reason why that statement is true. And most proofs in geometry are two-column proofs, but you've also seen some paragraph proofs and some indirect proofs and other things like that. So this is the one that you'll see the most of, so be prepared for that. All right, now we're going to get to the nitty-gritty of it. You have two parallel lines here. We can call this line A and we can call this line B, and we can say that they are parallel to each other. And when you have another line that cuts across those two lines in two unique separate places, that line is called the transversal. And it's going to be very important that you understand that the two black lines are parallel and the red line is the transversal that goes through those two parallel lines. And it can go through it in any angle, but it's all a transversal. So this is just one example. All right. Something else that I want you to see is that a transversal cuts these parallel lines into 8 separate angles. So you could number them out if you want to, but 1, 2, 3, 4, 5, 6, and 7, 8. And it always cuts them into those 8 pieces. Now those 8 pieces have relationships with each other. So those angles have different positions and different things that tell us about the way that they are related. The first of which is corresponding. So an angle that is corresponding will always be corresponding based on the parallel line. So our line A and line B are our parallel lines here. And so if we notice we have this angle here, we'll call this angle 1. Angle 1 is in the top left-hand corner of this intersection right here. So the angle that's corresponding to angle 1 will be in the top left-hand corner of this intersection right here. So this angle right there, angle 2, would be corresponding to angle 1. Some other ones here, I'll do the bottom right corner of this top intersection here. We'll call this angle 3. And then the bottom right corner of this intersection here would be corresponding to angle 3. The same holds true for the top right. We could call this angle 5, and the top right of the bottom line, call that angle 6. And of course, the same would hold true from the bottom left. Call this angle 7 and this angle 8. And those angles are corresponding. Now, what you'll learn in the corresponding angles postulate is that corresponding angles are always congruent. So corresponding, congruent. That's use that alliteration there to remind you. Corresponding are congruent. So in this particular example, angle 1 is congruent to angle 2. Angle 7 is congruent to angle 8. Angle 5 is congruent to angle 6. And angle 3 is congruent to angle 4 because they are corresponding angles. All right, so now we're going to move on to interior versus exterior. And interior versus exterior is referring to our two parallel lines here. So our green lines here. We have angles that are interior or inside our parallel lines, and we have angles that are exterior or outside our parallel lines. So interior angles would be 3, 4, 5, and 6. And exterior angles would be outside. They would be 1 and 2 and 7 and 8. And so interior versus exterior is something you're going to need to know, and that's always referring to the parallel lines. Now we have alternate versus same side, and this is referring to the transversal. So things might be alternating of the transversal, or things might be on the same side of the transversal. So here's our transversal here in red. So if it's on alternating sides, it might be angle 2 and angle 7. It might be angle 2 and angle 5. Anything that's on opposite sides of the transversal would be called alternate. And angle 1 here and angle 7 would be same side because they're both on the left-hand side. Angle 4 and angle 2 would be same side because they're both on the right-hand side of the transversal. So now we're going to move on to show you what alternate interior angles look like. So we're looking for interior angles. So we're looking for inside our parallel lines. So we're only talking about 3, 4, 5, and 6. Now alternate angles inside the parallel lines would be angle 4 and angle 5, and angle 3 and angle 6. And what our alternate interior angles postulate says is that alternate interior angles are always congruent. Anything that's alternate will always be congruent. Now we need to talk about same side interior angles. So interior, again, between our two parallel lines, so 3, 4, 5, and 6, and same side, so 4 and 6, and 3 and 5. Those would be same side because they're on the same side of the transversal here. So whenever we have same side, we always have supplementary. That's what our postulate's going to tell us. Same sides are supplementary. Corresponding are congruent, alternates are congruent, same side supplementary. And remember that supplementary means adds up to 180 degrees. So angle 3 plus angle 5 would equal 180, and angle 4 plus angle 6 would equal 180. All right, now we move to our exterior angles. So remember, exterior meaning outside of our parallel lines. So we're talking about angles 1 and 2 and angles 7 and 8 here. Those are exterior angles. And alternate exterior angles would be on the opposite side of the transversal here. So angle 2 is alternate exterior to angle 7. And angle 1 is alternate exterior to angle 8. Remember, all alternates are also congruent. I don't know why I drew a pie there. Let's try that again. Are also congruent. So all alternates are congruent. So 2 is congruent to 7 and 1 is congruent to 8. And now we do same side exterior. So we're only looking at the outside, angles 1 and 2 and angles 7 and 8. But same side, so this one here, angle 1, is same side exterior, same side of our transversal, would be number 7 over here. And then angle 2 would be same side exterior with angle 8 over there. Now remember, because they're same side, that makes them supplementary. So they add up to 180. So 1 plus 7 equals 180, and 2 plus 8 equals 180. So now let's do some review. Go ahead and pause to make sure you have the right answer. So what are the alternate interior angles of this photo? Pause. And here's our answer. 4 and 6 are alternate interior, 3 and 5 are alternate interior. And because they're alternate, they're also congruent. All right, let's try alternate exterior angles. Go ahead and pause. And our answers are angles 2 and 8 and 1 and 7. They're alternate exterior, and because they're alternate, they're also congruent. All right, let's try some corresponding angles. Which ones are corresponding angles? Go ahead and pause. All right, here's our answer in the green, 1 and 5, in the yellow, 4 and 8, in the blue, 2 and 6, and in the gray, 3 and 7. Those are the corresponding angles, and corresponding angles are congruent. All right, let's try some same side interior angles. Mark your same side interiors. Go ahead and pause. All right, we have 3 and 6 is one set, and 4 and 5 are the other set. And because they're same side, they are supplementary, and they add up to 180. And last but not least, let's try our same side exterior angles. Go ahead and